We are on slides 9 and 10, and this is about writing an equation from a word problem. So we are going to look at these word problems and come up with an equation so that we can solve a problem that goes along with it. So Jill opened a bank account with the $100 she received for her 14th birthday. To help save for a car, Jill decides to deposit $10 of her allowance each week into the account. So we need to talk about independent and dependent. We need to add a text box. So we need to talk about what depends on what. What are the two variables here anyway? The two variables would be the number of weeks and then how much money she has in her account. $10 is a constant and $100 is a constant. $100 is what she starts with, and then she adds or deposits $10 each week. So our independence, what depends on what? It'd be, let's see, account balance. Account balance depends on number of weeks. So this is going back to what's the independent, what's the dependent. I'm going to copy and paste these since I've already written them. And then we can talk about what is the independent, what is the dependent. Okay, so account balance depends on number of weeks. So if account balance depends on number of weeks, the account balance is our dependent variable. And our independent variable is what it's depending on, which is our number of weeks. Okay, so now we need to write as a function. Be sure to use proper function notation. Let's talk about what our M is and what our B is. So M is your rate of change. So in this story, what is the rate of change? 10x. Yeah, because 10 per week. 10 per week. So let's write that here. 10 is our rate of change. And then what is our B value? What did she start with? So that would be your initial amount. Yeah. How much? 100. So now we need to write it as an equation. So it's y equals 10x plus 100. So how can we find out how much money she'll have after 23 weeks? Multiply 10 times 23 and then add the 100. Let's do f of x. Let's write it as f of 23 because that's your function notation. Because x is 23. The number of weeks, x is 23. So equals 10 times 23 plus 100. So 10 times 23, what is that? 230 plus the 100? Yeah. So f of 23 equals 330. Let's write it as a sentence. Since this is a word problem, I got all tongue twisted. We need to write our answer in words. So how do we answer the question? How much money will Jill have after 23 weeks? Jill will have $130 after 23 weeks. So anytime there's a word problem, expect to make your answer in words, in a sentence, complete sentence. Okay, let's look at the next one. Bob is driving home from his vacation to see the Grand Canyon. When he stops to check his map, he notices that he is 320 miles from home. He calculates that he should be able to cover 60 miles of road each hour on his journey. We need to know the independent and dependent. So what are the two variables?
Miles of road each hour.
So that's your rate of change, right? 60 miles of road each hour. So what is your variable then with that?
The time.
Yeah. Number of hours would be one of them. And I'm not saying which one is independent, dependent yet. And then what's the other one?
The miles.
Yeah. The miles from home, right? Okay. I'm going to make two of those because I got to put that in two different spots. I haven't made the miles from home yet. Miles from home. Okay, so what is the independent? What's the dependent? What depends on what? Do number of hours depend on miles from home, or miles from home depend on number of hours? What do y'all think? Okay, who thinks miles from home depends on number of hours? Number of hours depend on miles from home? Okay.
I think it's the other one.
You think it's the other one?
Because the miles from home, like, depends on how far you are.
If you didn't have no miles, you wouldn't have no hours.
Yeah.
Right.
You can have hours without miles.
Because what's the X value if we think about our rate of change? 60 miles of road each hour. So what's the X value represent in that? Like what's the variable? Huh? 60 miles of road each hour. That's 60x. Number of hours is X. So number of hours is your independent. So then miles from home is your dependent. So then what depends on what? If this is the dependent and this is the independent. Miles from home depends on number of hours driven. Right?
But can you explain that again?
So you start out with 320 miles from home. Then you go 1 hour. And then how many miles do you have left?
I thought it meant like till you get like that point.
Well, that would be because you're going from 320 all the way down to 0 miles, right? So that one's a decrease, right? The number of hours, you start out at 0 hours and then you increase, 1, 2, 3, 4, 5. So if you think about what your graph would be, let's see if I can pull up my little document camera. Is it going to work? For some reason, this sometimes works and sometimes doesn't. It's not going to work today. Nope. Okay. Well, I was going to do a graph of what it looked like, but I can't get my thing working. Okay, so I got it working. So if you think about the graph, you're going to start at 320 miles from home, and then you're going to get closer and closer and closer. Your number of hours will be right here. And then your miles from home will be here. So you're going to start out at 320. Let's say 100, 200, 300. We went by 50s. This would be 400. So 320 would be right around here. And then you start out 0 hours, you're at 320 miles from home. And then after 1 hour, where are you at? What would that be? Mental math, Cal? 260. Okay, so this would be right around here. And then after 1 more hour, 200. Then after 1 more hour, 140. Then after 1 more hour, 80. So this would be right on here. After another hour,
20.
and then we can't, it would be at negative 40, right?
No.
So it'd be down here. But it's a constant rate of 60 miles per 1 hour. So about how long did it take to get home? How many hours do y'all think? 5.5-ish. Yeah. Okay. So this is our independent and this is our dependent. That's what we were getting at. And then I kind of got distracted and off on a tangent, but it's still the same thing. So miles from home depends on number of hours. So our dependent is miles from home. Then our independent is our number of hours. So what is our rate of change, our M? The miles per hour, 60. Make this bigger. And then what is our B, which would be our initial amount? 320. Okay, so then our equation, what's that? 60x. It's what?
Wouldn't it be subtraction?
Well, what's our initial amount? 320. And then what's happening each hour? It's what? Subtraction. So it's actually, you can do it like this, 320 minus 60x, or to do it in mx plus b form, it'd be because our rate of change is 60x plus 320. So our rate is a decrease of 60 per hour, and our initial amount is 320. And so that goes along with this, our rate being negative 60, because remember we are subtracting 60 every time. And then our B is 320. So it's y equals negative 60x plus 320. Okay, so how far from home will Bob be after 2.5 hours? How do we do this?
F of 2.5 equals 60 times 2.5 plus 2.
Yeah, f of, so we're going to do that same function notation. F of 2.5 equals negative 60 times 2.5. Let me move it so y'all can see it. Well, if I can. Oh no, I don't know what I just did. Plus the 320. So negative 60 times 2.5. Negative 150. Plus the 320. 170. Okay, so we need to write this in words. Okay, what will this be written in as, or in words? How can we answer this in words? After 2.5 hours, Bob will be 170 miles from home. Okay, how long will it take him to reach home? What was our estimate? Around 5 and some. Okay, so instead of this function notation, f of how many hours, we don't know what it is, but we know it's going to equal 0. So 0 equals negative 60x plus 320. We want to find out whenever he is 0 miles from home. X is number of miles. We want to find how many miles it'll take for him to get home. I mean, how many hours it'll take for him to get home. There we go. Okay, so we need to solve this equation. I'm going to use my composition book to solve it. So you go ahead and do the same thing. Okay, so 0. So we have to move the 320 to the other side. So minus 320. Negative 320 equals 60x. Negative 60x. And then divide by the negative 60. .3 repeating. But we want to know what this is in minutes. How do you determine what that is in minutes? How many minutes are in an hour? 60. So what we would do is we need to do point. Well, that'd be 1/3, right? This is really 1/3, 5 and 1/3 of an hour. What's 1/3 of an hour? 20 minutes? Yep. So it'd be 5 hours, 20 minutes. One third of an hour, which would be 60 divided by 3, which is the 20. So we would say x equals 5.3 repeating, which is 5 hour, 20 minutes. Then we need to write it as a sentence. It will take Bob 5 hours and 20 minutes to get home. Okay, let's look at slide 10. Marissa decides to offer a babysitting service to local families as a means to earn money to buy Christmas presents for her family. She decides to charge a flat fee of $15 for babysitting plus $4 per hour. Pretty cheap. So, what depends on what? What are our two variables? Number of hours, yeah, because you get the $4 per hour, so that's your rate. No, what's our total though? Because we have the flat fee, that's like your y-intercept. Then you have your rate, and then whenever you do the operation, let's say for 1 hour, what are you finding? Amount of money. So, amount of money earned. So we're going to need 2 of these. And then what's the other variable? Yeah. Number of hours. Okay, so what depends on what? What's our independent and what's our dependent? Yes, that's right. So amount of money is our dependent. Independent is our number of hours. So how do we write it as what depends on what? Yeah. Number of hours of babysitting, yeah. Okay, so what is our B value? I mean our M value? What's our rate? $4 per hour. That's cheap. I keep on saying that. Man. It's awesome. Not awesome for the babysitter, but awesome for the parent. Okay. Then what is our B value? What is our initial amount? 15. So then we need to write our equation. 4x plus 15. How much will Marissa make after a babysitting job that lasts 3 hours? How do we write this?
23 for X.
So f of 3 equals 4 times 3 plus 15. Is that right? Okay. So answer it in a complete sentence. So Marissa will make $27 for babysitting for 3 hours. Okay, the last one on this page. The Smith family owes Marissa $29. How long did she spend babysitting their children? So how would we figure out that?
27 is 3 hours, so another 4 hours, or another hour will be 29, something like that. And then half it is 3.5.
Yeah, great reasoning. Yep. So yeah, just like Ellie Kate said, we got $27 for 3 hours. If you do $4 more for another hour, but she only went up 2, so that means half an hour. If you were to solve this equation out, you would get 3.5. You'd subtract 15 on both sides. What is that? If we subtract 15, what do we get? 14? Okay. So 14 equals 4x. What's 14 divided by 4? I guess it's 3.5, huh? So as a complete sentence, Marissa babysat for 3.5 hours. Okay, so your assignment is to do these problems on slide 10. Just finish slide 10. I won't see y'all Tuesday, Wednesday, or Thursday because y'all are doing the interim testing. So on Friday, this needs to be done. No excuses. Just do it tonight so you don't forget about it.
So when will we know where we go?
I don't know.